Welcome to my channel. I'm Zhangjing Xu. In this one, we talk about the problem 17 in chapter 5. And you can see we have two boxes. We mark it as number 1 and number 2. They are at different mass. And then they just attach together and keep stationary on the horizontal surface. And then we apply a force, this one by the person, right, on this number 1 box, and tell you the kinetic friction. Ask you to find the acceleration of the system. So the first one, when we want to see the acceleration of the system, so the most easy way is to consider the number 1 and the number 2 box as a united one, right? So in this one, we consider number 1 and number 2 as united one, so we can say we need to consider force, the m1 plus m2 times the g, this is gravity for this united one, and the normal force, agree? And then the force by the person. And also we need to consider the kinetic friction. And then we can consider Newton's second law to write equations. First one is the y component. We have the F1 minus the gravity, the united one from gravity equals 0. And then because it's stationary, so we have Fp minus the friction equals the, oh no, it's not stationary. We need to find acceleration. So we use Fp minus the friction equals the total mass times the acceleration. Now the friction is equals to the kinetic friction coefficient times the normal force. This one. And then you can see if we input the normal force inside, we can get acceleration equals this one. Agree? So now it's very easy for us to get acceleration because in these functions, Fp, mass, and mu k are given. The next one asks you to find the force between each other, right? So in this one, I suggest you to look at number 2. Because we can see number 2, we just have the gravity, and we have normal force. The next one, we have the force applied by the number 1, right? The force 1, 2, 2, so F21, and then also the friction force. Do you agree? And then we can write Newton's second law to find the force between each other, that is F21, this one. This is what we want to find. So first one, look at the y component, we have normal force minus the gravity equals 0. And then at x component, we have the F21 minus the friction equals mass times acceleration. And acceleration is there. See, because this object, number 1 and number 2, keep the same acceleration. You agree? Because they just attach with each other, never separate. So acceleration are same. And then we can consider the friction as the coefficient times the normal force. And mu k m2g, and input the friction inside, we can get F21 equals this one. And when you see this one, on this equation, the acceleration is just there. So we can input the acceleration inside, we can get the force between each other. And then the third one asks you repeat with these two boxes reversed. That is easy. You just change the value, number 2 to number 1. Everything is solved. See, if we input the numbers inside the first answer for this one, we want to find the acceleration for the system is 1.7 meters per second square. The second one, we input the numbers about the acceleration and the mass, and the coefficient we find it is 430 newtons. And the third problem, we just change the number 2 mass to number 1, right? To number 1. Then everything is solved. Thank you.